Picture this. You walk into your garden early on a Saturday morning, coffee in hand, feeling good, and you notice something. Something between the squash leaves. Then you lean in closer and see it. Eggs. Hundreds of tiny copper-colored eggs lined up in perfect rows on the underside of the leaf. And next to that plant, another one, squash bug damage already spreading across the stem. But here's what stops you cold. 3 rows over, same garden, same soil, same summer, there's a single tomato plant that looks different from every other plant around it. The stem is thicker, the leaves are a deeper green, there's fruit on every branch, and there isn't a bug on it. Why? What is different about that one plant? The answer to that question changed how I think about gardening entirely, and it started with something I saw in the back of an Amish property in Lancaster County, Pennsylvania, a grafted tomato that was producing more fruit from a single stem than I was getting from an entire raised bed. And underneath the soil of that same plant, something else was growing entirely. Today, we're going to talk about the Amish grafting tradition, about a technique that is completely invisible in mainstream American gardening, that commercial seed companies have no financial reason to teach you, and that allows a single plant in your garden to produce 2, 3, sometimes 4 distinct crops from the same root system. If you stay with me to the end, I'll show you the step-by-step method that even a beginner can do at home, with a razor blade, a clip, and about 10 minutes. Let's start with something that almost nobody talks about. Both tomatoes and potatoes belong to the same plant family, the nightshade family, Solanaceae. They share enough genetic similarity that their vascular tissue, the internal plumbing that moves water and nutrients through a plant, can actually fuse together when the stems are joined. And once they fuse, you have one plant, one root system feeding 2 distinct crops, tomatoes above ground and potatoes below, at the same time, from the same stem, in the same square foot of garden. That technique has a name. Commercially, it has been called the TomTato, and a British horticultural company spent 15 years perfecting it before launching it in 2013. But the concept itself traces back at least to 1833, documented in a French gardening almanac. And in communities where people have been growing food for generations without a catalog or a corporation telling them what is possible, this idea never disappeared. The Amish did not invent grafting, but they preserved it, practiced it, and handed it down in an agricultural culture that has no reason to keep knowledge secret. You cannot sell a graft, you cannot patent it, you can give it away. And that is precisely why most of us have never heard of it. Here is what grafting actually is, stripped of any mystique. You take 2 plants. You make a precise angled cut through the stem of each one. You press those cut surfaces together so that the inner tissue, the thin green layer called the cambium, makes direct contact. You hold them in place with a small silicone clip. Over the next 7 to 10 days, those 2 plants slowly grow together into one. The rootstock, the plant whose roots you want, sits on the bottom. The scion, the plant whose fruit you want, sits on top. The roots of the scion are removed. The leafy top of the rootstock is removed. What remains is a single organism with the disease resistance and vigor of the root variety, combined with the flavor and fruit quality of the top variety. Farmers in Japan and Korea figured this out industrially before World War II, and today roughly 95% of watermelons grown in South Korea are grafted plants. The commercial tomato industry in the United States has known about this for decades. Major greenhouse operations graft tens of thousands of plants every season because grafted tomatoes produce for twice as long, resist soil disease, and outperform their ungrafted equivalents by a wide margin. Research out of North Carolina found that grafted heirloom tomatoes generated 21% more marketable yield than the same ungrafted varieties. One Missouri farmer reported that his harvest window went from 6 weeks to 20 weeks after switching to grafted plants. 6 weeks to 20 weeks. From the same variety, just by changing the root system underneath it. So why do not most home gardeners do this? Why is this not in every mainstream gardening book? Here's the part that stung a little when I learned it. There is no seed for a grafted plant. You cannot save a seed from a grafted tomato and grow another grafted plant. The graft is a physical union between two living stems. It exists as long as that plant lives, and then it is gone. To get another one, someone has to make another one. By hand, from scratch. For seed companies, that is a problem. You cannot sell a graft in a packet. You cannot patent a technique that any gardener can learn in an afternoon. So the industry defaulted to hybrids, to proprietary rootstocks with commercial names, and to a system that requires you to buy something new every year. The Amish defaulted to something else. They teach their children. Now let me walk you through exactly how to do this, starting with the technique that blew my mind the first time I watched it. The simplest graft to start with is a tomato on tomato splice. Not two different species, just two different varieties of tomato, where one has the disease resistance you need in your soil, and the other has the flavor you cannot live without. You start your rootstock seeds, a variety bred specifically for vigorous roots, like Maxiford or Estamino, about 2 days before your regular tomato seeds, because rootstocks grow faster. When both seedlings reach a stem diameter of about 2 millimeters, roughly the thickness of a wooden matchstick, you are ready. You work quickly, you work clean, and you work at a slight angle. Using a new sterile razor blade, you cut the top off the rootstock at a 45-degree angle and discard it. You cut the scion, your flavor variety, your heirloom, whatever you are actually trying to grow, at the same angle, removing its roots. You place the two cut surfaces together, cambium to cambium, and you clip them. That is the graft. That is all of it. The plants go into a healing chamber for about a week, keep conditions high, humidity and low light, and maintain around 72 to 75 degrees Fahrenheit. A clear plastic dome over a tray works perfectly. After 3 to 4 days, open the dome gradually to acclimate the plants. Within 10 days, the graft has taken. You have a new plant, one that will grow twice as long, fight off soil disease, and produce more fruit than either parent would have alone. But here is where the Amish approach gets more interesting, because they did not stop at tomato on tomato. Remember what I said earlier about the nightshade family? Tomatoes and potatoes share enough genetic similarity that their stems will fuse. The technique is almost identical to the tomato splice, but there is one additional challenge. Potato stems are often thicker than tomato stems, so match your varieties by size before you graft. A cherry tomato variety generally pairs well because the stems are more comparable in diameter. Once the graft takes, you cut away the tomato roots and the potato's leafy top growth. What remains is the potato root system driving a tomato plant above the soil line. Plant it in a large container or a deep garden bed. The tomatoes begin producing in summer. When the tomato tops start to die back in early fall, you dig the roots and harvest the potatoes. 2 crops, 1 plant, 1 square foot of garden. The science behind why this works is straightforward. The potato root system is extraordinarily vigorous. It has evolved to push deep into soil, draw up moisture, and anchor a plant through drought and disease. When you put a tomato on top of that root system, the tomato gets access to resources it could never develop on its own shallow roots. The result is a tomato plant that produces more fruit per stem and lives longer than it would otherwise, and a potato harvest that comes from a root system that was never competing with anything else. Think about that for a moment. Every other year of your gardening life, those 2 crops were using separate square footage, separate beds, separate water, separate fertilizer. The graft collapses that into a single plant. Now, I need to tell you something honest, because I do not believe in overselling. The potato harvest from a pomato plant is not as large as a dedicated potato bed. Some gardeners report getting about half the tuber yield they would expect from a solo plant. The tomato crop, on the other hand, often exceeds what a conventional, ungrafted plant produces. The overall calculation? 2 food crops, 1 growing space, no extra water or fertilizer, tends to come out well ahead. But you should go in with accurate expectations, not a fantasy. What makes the Amish approach to grafting distinctive is not just the techniques themselves, it is the philosophy underneath them. When you walk through an old Amish orchard, you do not see one tree for one variety. You see a single apple tree carrying 3 or 4 branches, each producing a different variety. An early apple ripening in August, a mid-season apple in September, a late keeper that stores through winter. All from the same trunk, all from the same root system. Multi-graft fruit trees have been a documented practice in European peasant horticulture and American heritage orchards for well over a century. The logic is straightforward and beautiful. A single tree bearing multiple varieties cross-pollinates itself. You do not need a second tree. The staggered harvest means you are picking fresh fruit for months instead of days. And because different varieties have different resistances to different fungal and bacterial pressures, the tree is more resilient than any single variety tree would be. Heritage nurseries still sell these trees. Combination apple trees with 4 or 5 varieties on 1 semi-dwarf rootstock are available to anyone who looks for them. What is rare is knowing to look and understanding why the multi-graft approach was standard in American kitchen gardens before large-scale commercial agriculture made variety and efficiency someone else's problem. The Amish never handed that off. There is a reason that grafting knowledge persisted in communities that did not participate in the commercial seed system. When you cannot go to a catalog, you have to remember. When you cannot buy a new plant every spring, you have to know how to make one. Grafting is precisely the kind of skill that survives in communities where knowledge travels person to person, hand to hand, generation to generation, and disappears in communities that outsource their food production to someone else. What I find remarkable, standing on this side of it, is how simple the technique actually is once you see it done once. A razor blade, a silicone clip, a plastic dome, 10 minutes of careful work, and then something that would have seemed impossible to me 5 years ago. A single plant in my garden quietly producing 2 different foods at the same time, through a method that predates any company that might have wanted to sell it to me. The Amish did not invent grafting. They just never stopped doing it. And now you do not have to either. If you want to try this at your own scale, here is where to start. Order a packet of rootstock tomato seeds. Maxifort or Estimino are the most common, and start them 2 days before your regular tomatoes. Get a bag of silicone grafting clips sized for 2mm stems. Work on a clean surface. Cut at 45 degrees. Keep the cut surfaces moist and move fast. Heal them in high humidity for a week. That first graft, even if it takes you 3 tries, will teach you something no article ever could. And if you want to try the tomato-potato version, start with the cherry tomato variety. Smaller stems graft more easily to potato stems, and a first early potato variety. Match them to similar stem sizes before you cut. Give the finished plant a large container, deep and rich, and water it more than you think it needs. The root system is doing double work. That is what I have been sitting with since I first watched a Lancaster County gardener casually splice 2 plants together in about 4 minutes, the same way she had been doing it since she was old enough to hold a blade. No drama, no product, no patent, just knowledge. Past forward. Hit subscribe if you want more of these. I have been spending time in communities where growing food has never been someone else's problem, and there is a lot more where this came from. I will see you in the next one.